Okay, so this is section 12.3, day 2. And so we're going to talk about adding up geometric series. So remember, with series, we're talking about finding sums. And so, again, we're going to talk about finding the sum of the first n terms. In other words, the nth partial sum. So, for example, we might have something that looks like this. So we have a summation, I equals 1 to 16 of 4 times 3 to the I minus 1 power. This is going to be a geometric series. The reason you know it's going to be a geometric series is because it has that a1 times r to the n minus 1 structure to it. Does everybody see that? When you have a number that's being raised to your I or your n or whatever as a power, okay, then that's typically going to be one of your geometric series. And guess what our r is going to be here? 3. Just like we knew d was going to be the coefficient of I, r is going to be the thing that's being raised to the I power, or in this case, the I minus 1 power. Does that make sense, everybody? Because it's that a1 times r to the n minus 1 idea. So, it turns out that the sum of this series, the sum of the first n terms, is equal to the first term times 1 minus r to the n over 1 minus r. This is our formula. So we need to know the first term, we need to know r, we need to know the number of terms that we're adding up. How many terms are we actually adding up here? 16, right? 16 minus 1 is 15, and then add 1 back in. Right? Remember, it's the top number as long as this is a 1, but if this is not a 1, you need to subtract and then add 1 back. Don't forget about that. Now we need our first term. How do I find the first term? Plug in what? Plug in 1. Plug in your starting value, whatever that happens to be. In this case, it's a 1, so 4 times 3 to the 1 minus 1. That's 4 times 3 to the 0. What is 3 to the 0? So the whole thing is just 4. So now we can plug it in. The sum of the first 16 terms is equal to 4 times 1 minus 3 to the 16th power over 1 minus 3. So do you see how I just plugged all those in? Now, do you guys see where the messiness is going to come from? It's going to come from this term right there. Especially if r is not a whole number. What happens when r is like 1/3? So in that case, what we're going to do, guys, is we're typically, it's okay with me if you write these as decimals, as your final answer. Okay? Leave them exact up until you punch it into your calculator, but then you can give me a decimal. So this is 4 times over negative 2. Let me get my calculator. I want 1 minus 3 raised to the 16th power is negative 430,46720. A huge number, right? Times 4 and then divided by negative 2. So times 4 equals, divided by negative 2 equals, and our answer is 860,93440. So this one didn't come out to be a decimal, but when r is not a whole number, they will almost always come out to be decimals. So look at this simple looking series, guys. My first term is 4. The next term is going to be 12, because we're multiplying by 3 each time, and then 36, etc. Doesn't it seem amazing that if I just add up the first 16 terms of that thing, I'm over 86 million? Geometric sequences grow at an extremely fast rate. You guys see that? 16 terms in, what is my total after 3 terms? What do those add up to? 52. After 3 terms, I'm at 52. I add 13 more terms, and I'm over 86 million. Okay? So they accelerate extremely quickly if r is larger than 1. Now, if r is less than 1, it's a different story, and we're going to talk more about that tomorrow. Okay? But does everybody see how the formula works? So, you guys are going to be asked to do some pretty straightforward things. They're going to give you problems with the sigma notation. So what if they give you one that looks like this? What if we have the summation I equals 1 to 7 of 2 times 1/3 to the I minus 1. So we have to find A1, we have to find R, we have to find N to use our formula, right? So how many terms are we adding up? 7, right? 7 minus 1, add 1 back in, gives us 7. What's our R going to be? 1/3. How do I find A1? Plug in the 1 for I. So 2 times 1/3 to the 1 minus 1 is 2 times 1/3 to the 0, which is really just what? So A sub 7, I'm sorry, did I say A before, guys? It should be S sub 7. Did I mess up on that? No, I was all right. I did S16. Sorry about that. S sub 7 is equal to, so the sum of the first 7 terms is equal to the first term, A1, times 1 minus R to the nth over 1 minus R. This is 2 times this over 2/3, right? Because 1 minus 1/3 is 2/3. That's really 3 over 3 minus 1 over 3. Everybody with me on that part? Now we have to do this guy. So I have to do 1 minus 1/3 to the 7th power. On my calculator, I'm going to do parentheses. Actually, I'm going to do 1 minus parentheses 1 divided by 3, close parentheses, raised to the 7th power. Notice this gives me a decimal, 0.99954275. And it goes on and on forever. What we now do is I leave that in there, I multiply times 2, and then I divide by parentheses 2/3. And I get an answer that's going to round off to about what? 3. So that's about equal to 3. Questions about that? Now, typically, you'll round off to, let's say, 2 decimal places unless they specify otherwise, but this one ended up rounding all the way up to 3.0. Yes, ma'am? Right, top minus bottom plus 1. Right, remember, that's just the number of terms that we're adding up. So we can tell that just from the index on the sigma. Make sense? Good. Okay, any questions about those? That's it, guys. That's all there is to it. It's messy, but is it really hard? No, you have to remember the formula. It's the 4th of our formulas to memorize. But it's pretty easy to work with. It just gets messy, but your calculator helps you out. Okay, let me give you the assignment then.